So, hello to my fellow engineering students. So, this is the uh, continuation of the riveted connections report. So, let's start. So, the types of riveted joints. So, the following are the two types of riveted joints depending upon the way in which the plates are connected. So, number one is the lap joint. So, a lap joint is that in which one plate overlaps the other and the two plates are then riveted together. So lap joints are the following two types. So the first type of the lap joint is the single riveted lap joint. So the riveted joint has one row of the rivet in a lap joint or when there is only one row of the rivet on each plate of butt joint. So as you can see in the figure, so it is stated that the single riveted lap joint. So next is the double riveted lap joint. So two rows of rivets are used in a lap joint or two rows of rivet are used in each main plate of butt joint. So the other type of the riveted joint is the butt joint. So a butt joint is that in which the main plates are kept in alignment, butting each other and a cover plate is placed either on one side or on both sides of the main plates. The cover plate is then riveted together with the main plates. So butt joints are the following two types. So number one is the single strap butt joint. So the edges of the main plates butt against each other and only one cover plate is placed on one side of the main plates and then riveted together. So based on the figure given, you will see the single riveted butt joint. Next is the double strap butt joint. So the edges of the main plates butt against each other and two cover plates are placed on the both sides of the main plates and then riveted together. So ang pinagkaiba nitong dalawang ito is pag sinabing riveted butt joint is isa lang yung rivet niya on both sides. While on the double riveted butt joint is dalawa yung rivet niya on both sides. So let's discuss the failures of a riveted joint. So a riveted joint may fail in the following ways. Number one, tearing of the plate at an edge. So a joint may fail due to tearing of the plate at an edge. This can be avoided by keeping the margin. So M is equal to 1.5 times diameter. So the figure 1 illustrates the tearing of the plate at an edge. So the next failure of the riveted joint is the tearing of the plate across a row of rivets. So we know that tearing area per pitch length is area is equal to P minus D times T, where P is pitch of the rivets, D is the diameter of the rivet hole, and T is the thickness of the plate. So therefore, tearing resistance or pull required to tear off the plate per pitch length is PT is equal to 80 times the tearing resistance or equal to P minus D times T times the tearing resistance, where PT is the maximum pull acting on the joint. So when the tearing resistance is greater than the applied load P per pitch length, then this type of failure will not occur. So the figure 2 shows the tearing plate across the rows of the rivets. Next failure of the rivets joints is the shearing of the rivets. So we know that shearing area is equal to pi over 4 times d squared in single shear, while in the double shear is 2 times pi over 4 diameter squared. So therefore, shearing resistance or pull required to shear off the rivet per pitch length is is equal to N, where N is the number of the rivets, times pi over 4 times d squared times T, where T is the say permissible shear stress for the plate material. So when the shearing resistance PS is greater than the applied load P per pitch length, then this type of failure will occur. So lastly, the last failure of the rivet joints is the crushing of the plate of rivets. So the crushing area per rivet in a projected area per rivet, AC is equal to diameter times the thickness of the rivet. So therefore, the total crushing area is equal to N times D times T, and the crushing resistance or pull required to crush the rivet per pitch length is PC is equal to N times D times T times OC, where OC is equal to permissible tensile stress for the plate material. Take note that the number of the rivet under shear shall be equal to the number of rivets under crushing. So let's move on to the efficiency of a riveted joint. So the efficiency of the riveted joint is defined as the ratio of the strength of riveted joint to the strength of the unriveted or solid plate. We have already discussed that strength of the riveted joint is equal to the list of the PP, PS, and the PC. So PT is the maximum pull acting on the joint, PS is the shearing resistance, PC is the crushing resistance or pull. So the strength of the unriveted or solid plate per pitch length is equal to P times T times OT, where, as I said before, OT is the permissible tensile strength or tensile stress for the plate material. So therefore, the efficiency of the riveted joint is equal to the list of the PP, PS, and PC all over P times T times OT. So let's take a sample problem of the butt joint. So let me read the problem. So a double riveted cover butt joint in plates 20 millimeter thick is made with 25 millimeter diameter rivets at 100 millimeter pitch. So the permissible stresses are OT is equal to 120 MPa. So T is equal to 150 MPa. OC is equal to 150 MPa. So find the efficiency of the joint taking the strength of the rivet in double shear as twice than that of the single shear. So let's take a look for the given value or given data. The thickness is equal to 20 mm. The diameter is equal to 25 mm. P is equal to 100 mm. OT is equal to 120 megapascal or 120 Newton per millimeter squared. And T is equal to 150 megapascal. OC is equal to 150 megapascal or equal to 150 Newton per millimeter squared. So solution. So first of all, let us find the tearing resistance of the plate, shearing resistance, and the crushing resistance of the rivet. So the first step is the tearing resistance of the plate. So we know that the tearing resistance of the plate per pitch length, as discussed in the previous slides, is PT is equal to AT times OT is equal to P minus B times OT. So from the formula, we will substitute the given value. So where P is 100 minus 25 times 20 multiplied by 120. So the answer of the tearing resistance is 180,000 Newton. So next step is determining the shearing resistance of the rivet. Or since the joint is double riveted butt joint, therefore the strength of two rivets in double shear is taken. So we know that the shearing resistance of the rivet is equal to N times 2 times pi over 4 times d squared times T. So let's substitute from the given value. So we have 2 times pi over 4 multiplied by 25 squared times 100. So we have the shearing resistance of 196,375 Newton. So the last step before we identify the efficiency of the joint, so the crushing resistance of the rivet. So since the joint is double riveted, therefore the strength of two rivets is taken. So we know that the crushing resistance of the rivets is PC is equal to N times D times T times OC. So PC is equal to 2 times 25 times 20 times 150. So we get the answer of the crushing resistance of the rivets of 150,000 Newton. So after determining the failure of the riveted joints, so we will get the efficiency of the joint. So we know that the strength of the unriveted or solid plate is P is equal to P times T times OT. So we have the 100 times 20 times 120. So we get the load of 240 Newton. So for determining the efficiency of the joint, so therefore the efficiency of the joint is list of PT, PS, and PC all over the PT, P times T times OT, where the list of the PT, PS, and PC is equivalent to 150,000 that is calculated earlier, all over 240,000, which is the P computed before. So we get the answer of 0.625 or 62.5%. So the efficiency of the joint is 62.5%. So that is the answer. So that would be all for the report of riveted connections.